Okay. So in the previous lecture, we have talked about short range communication, right? Now we will talk about long range communication, right? So we'll go to let me share. So we will talk about long range communication. Okay. So as we are aware of, for the long range communication, basically we used 2G, 3G, 4G, right? Because when we want to talk for a long range, like BTS, maybe 1 or 2 or 3 kilometers, we use the mobile services and we used to talk or send the data files, right? So in the long range communication for IoT case, there are two divisions. One is the license spectrum, and another is unlicensed, right? The license spectrum, we are all aware of 2G, 3G, 4G, and of course we're going to talk about the 5G itself. In the unlicensed for IoT, there are Sigfox and LoRa. I stand for long range, and there are many, right? Here Sigfox and LoRa, for both you need to pay to use this service, right? But their range are quite large. Basically the LoRa operates on 433 megahertz, and there are a company that is called LoRa Alliance, and it's takes care of, but its footprint is limited when you compare these 2G, 3G, and 4G and 5G, right? So basically today we are going to discuss the license spectrum, and more specifically we are going to discuss 5G communication for the IoT, not total 5G communication. Why 5G is suited for the IoT? Believe me, I'm not going to discuss 5G communication. I'm going to discuss 5G communication for IoT. Because discussing 5G communication itself a huge topic, it's a subject. Right? So now I'm going to discuss 5G communication. Okay. So let me share the slide. I hope this slide is visible to all. Right. Thank you. So we are going to discuss 5G NB IoT, right? And in this lecture, we are going to discuss basics of how 5G evolved for the IoT, and some of the basic architecture we are going to discuss for the IoT, right? So outline, introduction we're going to talk about, then LT2 for MTC, a long-term evaluation you might have heard of. 4G LTE, your phone might be receiving a signal. MTC applications, machine type communication, and then 4G to 5G. Of course, it is very much important, right? So as initially the wireless communication came into the picture, and it was evolved from 1G to 4G, and today we are using 4G communications, right? So the evolution from 1G to 4G is driven by the necessity, right? When we have 1G, just see, when we have 1G, we talk about only the voice communication. Then we have 2G, then there is voice plus data, but data rate is very much small. Right? So 1G is evolved from 2G, then we have 3G. Right? But 2G was focused on voice communication as well as the data communications. But the data speed is quite low. So what people have evolved, they have evolved for 2.5G, and 2.5G was edge. So in edge, the voice remain the same, but data rate improved, right? The voice remained the same, but the data rate improved. Now after that, there is a group which are having task, or they have made a group to have the standard for next generation communication technologies, right? So this group is known as 3GPP, third generation partnership project. And this group is formed to make standard for new communication technique for commercial use. And once this group is formed, it start releasing its standard in the form of release, like release 1, release 2, and so on, right? And it keep on releasing its standard in the form of release. They came up with 3G. So the 3G is introduced by 3GPP. This is the first technique. 3G was introduced by 3GPP, right? And it is more suitable for uh, data centric application, right? And the voice is nearly remain the same. So in 2G also we talk to the voice. In 3G also we talk with the voice. In 2.5G we also we have the voice communication. But once we keep on evolving from 1G to 2G, 2G to 2.5G, and then 3G, the data rates keep on improving. And the 3G, which is introduced by 3GPP, its standard is introduced in 3GPP, was released in release 7. In the release 8, 3GPP proposed a new communication technique known as 4G LTE, right? So in 4G LTE, LTE stands for long-term evaluation. In 4G, they have talked about more or the improved data rate. So what they have used? They have used a MIMO. They have used OFDM. Some of the terms are there. I'm not going to discuss much in detail because there are people from computer science, mechanical, instrumentation, so they might not be familiar with these terms. So there is no point in discussing in detail. So quickly I'll tell about what is MIMO and what is OFDM. So So MIMO is nothing but multiple input, multiple output. So in that case, the transmitter have multiple antenna, and the receiver can also have the multiple antenna. Here OFDM, orthogonal frequency division multiplexing. Here we do multiplexing of signal in terms of frequency, and they are orthogonal to each other. That means one carrier is like, suppose this is the, I want to draw the spectrum. So this is the one carrier, this will be the another carrier, this will be another carrier, something like that. The successive spectrum is orthogonal to each other. Okay, I'm not going to discuss much in detail. Now, once LT is there, the 3GP keep on giving the improved standard for the next communications, and they keep on giving release 8, release 9, release 10, and so on. And something in the form of last release like 15, 14, they have talked about the 5G communication, right? So in the release 13, they have proposed a standard for MTC, that is machine type communication, right? Now the question is, what is MTC? I should not ask it. Okay, already given. Otherwise, I wanted to ask someone. Okay, no problem. So in machine type communication, what happens? A machine automatically talks to the different machine, and that is the whole motto of IoT. If you remember, some books they also refer machine type communication to IoT communication. So you can find some of the books. There is no problem at all, right? So MTC is nothing but a machine automatically talks to a machine, and the framework for that was released by 3GPP in the release 13. Right. So there they have mentioned what should be the condition or what should be the standard for the machine type communication. And in the machine type communication, basically there are two types. One is machine to server and another is machine to machine. So for that they have given the standard. Application of machine type communication, I mean, machine type communication can have various applications, right? Industries, healthcare, manufacturing, energy. I mean, there may be a lot of application. And in fact, machine type communication support a multi-hop network, ad hoc network, mesh topology, right? And IoT, as I was discussing earlier, IoT was one of the realization of machine type communication. But it has, this IoT has a bracket on the range, complexity, power, right? So IoT, as we are aware of, since we are discussing the long range communication, so we are going to focus on long range communication. But still, our focus will not deviate from the low power consumption, because the utmost important is low power. Right. We always talk about low power, whether it is short range communication, whether it is long range communication. Right. So IoT is one of the low complexity. Here we are discussing long range because we are targeting the application to be long range. Right. Now just see a 5G application of IoT communication. So this is a 5G E not B, right? And it is receiving various data from the various places, like it is receiving from a smart building. A smart building can have many devices. It can have electricity meter, it can have smart doors, uh, now there people are coming with smart kitchen. uh, it it may have other sensors also, like temperature sensors, I think other sensors. So all those sensors are generating the data over here, and they are sending to E naught B. E naught B is nothing but, you might have aware of BTS, and in more layman term it is called tower. I should not use this word tower over here because this seems to be very much layman type, but still I'm using. So you might have seen the mobile towers in your area, and that is communicating like similar, like your mobile is communicating, right? Similarly, you can have gas station. There are many, like your car is connected, and then your car is sending data to the BTS, that the payment can be automatically made, something like that. There are a lot of application over there. All those data which are collected by this PTS will be sent to the core network, and from core network we can send it to the internet, or maybe I'll write it cloud. This is the operating principle of a uh, 5G scenario of IoT communication. One can argue there may be a single device over here. All this data is receiving by single device, and then single device can communicate with InRB. So there may be different way to send the data, but this is the whole structure of using this 5G. Now, uh, people are thinking, why we have gone to 5G? Why not like 4G was there, data rate was very good, and as I already told you, IoT devices generate a small amount of data, right? Right, a small amount of the data IoT generates. So there was already 4G, there was 3G. Why we have not gone to the 3G or 4G to send the data? Why we have gone to the 5G? The answer of this question is, this 3G, sorry, 3G and 4G, they are designed to have large data rate, but there is a limitation in terms of how many devices connected. So I'll write over here, limitation. Okay, someone wants to join. Let me. Limitation in terms of number of devices. Right. Uh, if you have any question, you can ask. Otherwise, please switch off your mic. Thank you. So, limitation in terms of number of devices connected to either 2G or 3G or 4G. This is the one of the limitations. The second limitation is application scenarios. So when they are evolving from 3G to 4G or 2G to 3G, they have only keep into the mind that it will be catering the voice call need and the data need. And when they focus to 3G and to the 4G, they only focus on improving the data rates. I think we all are aware of, but they never thought of application specific scenario, right? And they never thought of these many number of devices are going to connect. Because if you remember the previous class from me also and from the other speaker also, there are going to be 100 billion devices. And believe me, out of 100 billion devices, I believe around 50 to 60% will connect to the 5G. So you can imagine the numbers of how many numbers of devices are going to connect to the 5G. So therefore, there is a need to accommodate the large number of devices to be connected. So the 4G evolved to 5G, and the main focuses are the number of devices. Of course, there are various other parameters. I'm not denying the fact. There are various other parameters that we will discuss. So therefore, we always talk about the communication when we talk about the IoT communication. Then we talk about the 5G. And one category that MTC is 3GPP NB IoT, is also known as LTE narrowband thing, Internet of Things. And as I told you, this protocol is optimized because we already have 4G and we are moving towards 5G. So there is need to accommodate those applications, and therefore this LTE protocol, which is 4G, was optimized for NB-IoT such that it has low power consumption, low data rate, extended coverage, low hardware cost, and low bandwidth. Why low hardware cost is necessary? Because if you just see the price of a 3G phone is less as comparison to 4G phone and is less as comparison to the 5G phone. And now we are talking about deploying the 5G devices for IoT application. So the price will, if we will conventional 5G device, the price will increase. Therefore, we need to change or optimize such that are the requirement of low power, low complexity, low cost, as well as the low bandwidth meet our desired specification, right? So what happened? To do that, they have come up with a light version of full-fledged, oh sorry, they have come up with a light version of, okay, I'll mark over here, light version of full-fledged LT. That means this will be only suited for IoT applications, right? And therefore 4G is evolved such a way to 5G that it can accommodate large number of IoT devices. So I'll just see 4G to 5G how we have gone through. So 4G was introduced in release 8, right? And it was meant to be satisfy the IMT 2000. I'm not going much detail of IMT 2000, but if someone require, I can send you the material, right? What are the standards for, or what are the requirement for IMT 2000, right? So when 4G came into the picture, right? So it has a capability of higher data transfer rate, right? If the system capacity is large, spectrum efficiency was also good, and we have also low latency. Latency is nothing but the time taken by a packet from sender to receiver. So these are the things we have applied. Already I have talked about the multi-antenna support, right? When I was talking about MIMO systems. So all those things which are there into the 4G standards. Now, after the release 8, they have improved. They have released 9. So there they improved some of the parameters for the 4G, and then they have released 10. And in release 10, they have talked about IMT advanced requirement. They have talked about IMT advanced requirement. You can Google is the Google what is IMT 2000 requirement, what is IMT advanced requirement, and what is IMT 2020 requirements. I'm not going to much detail because I'm keeping a view on my audience also, because most of them are not be aware of these are the requirements. But for the sake of terms, you can understand. Otherwise, if you go much deeper into these requirements, you can go to the ITU website, right? So what happened in release 10? They have released IMT advanced requirement, and they have 1 Gbps transfer speed for the download and 500 Mbps for the upload. In initial the 5G, 4G, the upload speed was only 300 Mbps, and the download speed was 300 Mbps, and upload speed was 75 Mbps. So if you see, in the case of advanced LTE advanced, they have successfully improved the speed of data rate, right? So sorry, they successfully improved the data rates in both downlink, download or upload, right? Next, in addition of that initial 4G, it has also supported a large number of MIMO, right? Then we have a release of release 13, and that is talk about LTE Advanced Pro. It was released in 2016, and it is believed to the BB pre 5G activities. The release of 13 is, we can imagine like the birth of 5G. Now just see, here I have compared here I have compared different parameters for the release of IMT advanced, the requirement of IMT advanced and IMT 2020. I have not put here the IMT. Okay, sorry. IMT 2000 requirement I have not discussed, because already IMT 2000 requirement to we have IMT advanced requirement. Just see. So in IMT advanced requirement, what are the parameters? So first I'll talk about the latency. In IT advanced, they have talked about the latency of 10 millisecond. They have mobility. It can cater up to mobility of 350 kilometer per hour. Spectrum efficiency. Then we have talked about the user experience data. So user can experience a 10 Mbps of data. Peak data rate, it was 1 Gbps. As already told you, IMT advanced. Now the area traffic capacity. So area traffic capacity was 0.1 megabit per second per meter square, and the network efficiency was there. And then the main thing is the connection density. So here, if you carefully see, the connection density was 10 power 5 devices per kilometer square. It can handle up to 10 power 5 devices per kilometer square. Now, when 5G came into the picture, it comes with these many requirements, and these requirements are less latency. I will discuss where the less latency requirement is there. From 10 millisecond to 1 millisecond, latency is right. Now, higher mobility. The user can travel up to 500 kilometers per hour and still they have the connectivity. Spectrum efficiency is also improved. User experience data rate is improved. We have improved our peak data rate to 20 Gbps. Improve the data rate of okay. Give me some time. I think I need to take a call. Sorry for the interruption. So just see, here the rates are 20 Gbps and the area traffic capacity is also improved by 10-fold. The network efficiency has improved 100-fold, and again the number of devices has improved to 10-fold, 10 power 6 devices per kilometer, right? So if you see carefully, these IMT 2020 requirements are designed such that it can cater the need of IoT communications. Like what are the needs? Latency is one of the needs. In some application, we require a less latency. Connection density is also one of the requirement, and of course, the area traffic capacity. These are the three requirements, and of course, this mobility is there because when you talk about the connected vehicles, right? So these are the requirements. These are the requirements which are designed by IMT 2020, and 5G is believed to be satisfying all those requirements. So if you carefully see, it evolved towards the IoT communication because it improves in terms of latency, area traffic capacity, mobility, as well as connection density of the per kilometer area. So now we'll talk about the feature of 5G for IoT. So 5G technology promises a large number of state-of-art features, including narrowband Internet of Things. So we will be only focusing on narrowband Internet of Things, right? So as I told you, it will cater the needs of various applications like vehicle to vehicle communication, vehicle to everything communication, connected cars, machine type communication, device to device communication, and they have small networks, small cells, and the relay network. In addition to the MIMO and advanced antenna techniques, the 5G have adaptive beam forming, using of FDD, subframe, and OFDM numerology. These are the terms I'm not going to discuss into much detail because it will require a lot of time. So initially, the 5G terms were came into the release 13, then they have improved some of the standard for 14 and as well as 15. So the second point, if you see, NB-IoT is designed to connect a large number of devices, right? This is one thing, and this is the second thing. Connected devices are communicated through cellular infrastructure because in the short range communication, they used to talk through a coordinator. Here they are going to talk through a cellular infrastructure, and the advantage of this cellular infrastructure is the footprint of cellular network. I mean, in all across the world, a cellular network is present. So if you designed any of your IoT system that is working on cellular network, it is only for, you don't need to worry of this footprint of available network or not, right? 3GPP, as we have discussed earlier, they are suitable for different data rates. Like one, they have, sorry. So like 10 kbps, and they can go up to 100 kbps or more than 100 kbps depending upon our application. Why I'm saying so? Because 10 kbps may be suited for measuring a temperature of any physical environment, but maybe for connected cars we require hundreds of kbps data rate with low latency. So depending upon the requirement, they have given us set of or the different type of data rates. Of course, again, this NB-IoT is a low power wide area network. In the previous, when we talk about Zigbee, that was WPAN, personal area network, right? And the biggest advantage of using 5G for IoT is this, which I've already discussed in the previous slide. So as we are aware of, LTE is having big ecosystem. In fact, most of the countries is having LTE for voice as well as the data application. So we need to improve some of the standards such that the same ecosystem or the nearly the same infrastructure can be utilized to connect the IoT. Now, if you see 5G technology usage scenario, this is very much important when we try to understand why a 5G is a necessity, why we have not connected 4G to IoT. So just try to understand. I think there is a spelling mistake. This is massive machine type communication. Okay. So there are 3 points. One is massive machine type communication. One is ultra reliable low latency communication, and other is enhanced mobile broadband. Just see. So here those devices at this end or this corner, they have large in number and they are generating a small amount of data. Their number are large, right? Here, okay, here we cannot, what we can afford is where there is, if there is if the data rate is small, what we can afford is a small data rate, and we can afford the latency. Large latency we can afford, right? Because these sensors are like gas sense, electricity sensors, temperature sensors, or Wi-Fi, other sensors, like they are there. So we can afford the data latency of maybe 1 minute or 2 minutes. Like suppose your gas meter is there or electricity meter is there. So they are designed to send the data maybe after 15 days or maybe 10 days, not on the regular basis. And the data is still very small. So here we can have a freedom of large latency and small data. Sorry. The second term is over here at this point. We have machines which require higher data rate. Higher data rate. The number of machine can be moderate and latency can also be moderate, right? At this end, just see, at this end, we have low latency component. That means if we are having self-driving cars or emergency vehicles like ambulance, right? So these devices can be mapped here such that a self-driving car cannot have large latency. Like suppose the car is driving autonomously, and if it detects some person on the road or maybe some detects some disturbance on the road, it cannot afford a large latency, otherwise there will be an accident, right? And all those other applications can fall into this inside these 3 point. So depending upon these application, we can choose our 5G communication for our purpose, right? So that's depend upon which application you are going to target. And of course, just see, they have written is future IMT. So these are the application they are keeping into the mind, and then they are coming with the improved 5G. And in fact, there I'm also listening the term 6G. I'm not sure how much people have worked on that, but still I have found some of the papers they are targeting the 6G. So now I'll talk about the requirement and goals of the 5G NB IoT devices. So massive number of low throughput devices, low power consumption, longer battery life, improved indoor and outdoor coverage, low complexity, low latency, low cost. So I'll discuss one by one. So first we'll take massive number of low throughput devices. Like in an area, suppose I'm talking about an area which consists of, let us say, 10,000 houses. right? Every house might have equipped with 5 number of devices which are generating a small amount of data. Right? So they are generating a small amount of the data. Now, if I'm taking the average, these sensors are like gas meter sensor, electric meter sensor, and other sensors, right? So in that area, we have 50,000 devices need to be connected to the network, right? 50,000 devices need to be connected to the network, and their data, which is usually required to be sent, is very much small, a small data per device, or a smaller data, I'll write, right? So the goal of 5G NB IoT is such that it can support massive number of low throughput devices. The second important part is low power consumption, and I hope up till now, whether it is small range communication or long range communication, we always talk about the low power consumption. The third thing is long battery lifetime, which is already required. Improved indoor and outdoor coverage. It is very much required when we are talking of critical application like connected cars, right? Sorry. Connected cars, right? So there, if there is if there is no coverage present over there, the car will not able to talk to its network, and then there may be a collision or maybe an accident. Low complexity is required. Low complexity is required because if the complexity increases, the power consumption as well as the cost of the device will increase. Already I have discussed the case scenario for low latency, and of course the most important thing is low cost, because suppose in an area if there is a 50,000 devices, the cost must be low, right? So these are the requirement and the goals of 5G NB IoT devices. Now we'll talk about the requirement and goals of cellular networks. These are the requirement of devices. These are the requirement of cellular network. So the network must have power saving procedures, and power saving procedure can be implemented or can be achieved by implementing sleep mode, right? So they can introduce a sleep mode such that if you can see in the previous case also there was a sleep mode. So what happens, a device send the data and go for the sleep, right? It was intended to support SMS, short message service, support IP header compression, right? And also support reselection procedure for both idle and the connected mode. I'm not going to discuss the 5G idle mode and connected mode because there is no time, otherwise I should have been discussed. And support multicast traffic, that is kind of a broadcast, but broadcast and multicast is slightly different. In multicast, the traffic is from a large number of devices, but not from all those devices which are in the vicinity. While in the broadcast, it is supposed to be all those devices. I've given here is a typical example. So you just see number of devices and number of data generated. So there is a large number of devices over here. Sorry, and these are the application of a area like maybe some developed area. They are having water meter, gas meter, waste management, sensors, pollution monitor. I mean, there are a lot number of devices, and there if you see their frequency, how they report, what are the data bytes. So if you see, they report in either one day or twice, right? And the data is really small. So it is an example of massive throughput devices. Now we'll talk about the protocol stack. So I'll go to here. Okay, just say. So as we are aware of, okay, if you have any question, can I take the question and then I'll proceed. Okay, I'll take the question. If you have any question, please. I think one chat is there. Okay. If you have any question, you can type. I hope there is no question. So, okay, no issue. I think I got a question. Okay, I'll take the question and then. Okay, first question is traffic congestion increases. What happens to the power? Of course, if there is a congestion, very good question. If there is a congestion, the device will keep on trying to send the data. And if it keep on trying to send the data, it will drain the battery. I'm totally agreed with that. But therefore, that is the only reason why this 5G things came into the picture. They can support large number of devices. Therefore, congestion can be reduced. Okay. Next question is, okay, millions of devices connected, what impact it will be on our health, and so many signals are transferred. Okay. Look, already we are having, I think, around 5-6 billion mobile phones, maybe 4. I'll count it 4 billion. So already we have the 4 billion mobile phones. Maybe someone operating 2G, someone is operating on 3G, 4G, and 5G. So already we have the ecosystem, right? The point of the health is still under the discussion, because in many places, I'll also give you the example. In many places, initially it is believed that where COVID is having larger impact, where 5G have been deployed, what people have thought of, right? But still there is no evidence that 5G is causing COVID to be spread. I understand your question, because not only the 5G, when 4G, 3G came into the picture, people are after that there is a health impact. In fact, there is a professor from IIT Bombay, Professor Girish Kumar. Some of you might have been heard of that. He is the very vocal for these regions, the health impact of due to these radio signals. So he used to put his case in the to the government as well as to the public also, but still there is not much evidence that these signals are harming our day-to-day life or our health. So but still I believe if there is any health concern, uh, the agencies like FCC in USA, ITU, or ITU, they will keep on a note on that, and they will uh, they will try to not impose those things which is not good for health, which is injurious for health. So they will not try to impose those technologies. But still I feel that the impact of 5G on the health is not yet been studied in much detail. Some people are discussing that for sure. Any more question? Okay, no problem. I'll go to the slide. I quickly finish it by this 1:30, because next speaker will be from 2:30, so that cannot be delayed. And you also have to do the lunch. So okay, so if you compare the OSI model, so similar to the OSI model, in 5G also we have a kind of OSI model, and these two are called access spectrum, and the next 5 are called non-access spectrum, right? So the access spectrum are two bottom layers, and they are handling for the physical transmission. They are responsible for handling of physical transmission of the data. And I'll directly come to this point. So there we have just see physical layer, out of this MAC layer, RLC, PDCP. These are the 3 layers we had. And then we have non-access spectrum layer. So these 2 layers you can think of those 5 layers of OSI model. So quickly I'll go through how communication is done in this 3GPP model, right? Okay. So what happened? One radio wearer, it's have SDU, that service data unit oh sorry. So what happened? I'm quickly covering this. So this will add an header sent to the lower layer. This lower layer will also send a add an header and send to this RLC sub layer, and then it will add an header and send to the MAC layer. So similar to what we have seen in OSI model, that is happening through this, right? And then we have physical layer, and from physical layer we can send it. Okay, I think one of the things I have missed. Okay, now how the communication is done. So I'm running very fast. Okay, so there is E naught B. Again, E naught B is there. There we have MME, mobile management unit. So two E naught B or two base station are connected through X2 protocol. The one base station or E naught B is connected to S1 protocol to MME. And again, I'll quickly come to how the data is transmitted from user equipment to E naught B. So this NAS decided on when to transmit the data. Then it is transmitted, sorry. Then it is transmitted through, the data is first come to the PDCP layer, then the RLC layer, then the MAC, and then the physical, and similarly it will follow the same path, right? So it is very similar of what we have seen for OSI model data transfer. Only the interface I'm talking about service gateway, packet gateway, home server, right? So the home server have the information what are the capability of user equipment and what are the services it has subscribed, right? So it all those information it has. So first it will connect to the E node B, and from the E node B it will connect to the service gateway, right? And so from service gateway it will check what are the it will inform to NAS, and NAS will check what are the services the particular user is subscribed, and depending upon those services it is allowed to connect, or it is allowed to send, or how much data is allowed to send. Quickly I'll go through the modes of operation of NB-IoT. So there are three modes of operation: in-band, guard band, and standalone. So in in-band mode, one of the spectrum of LED or one of the band of LTE is allotted to do the communication for IoT. In the guard band, we are aware of there is a guard between two channels. So this guard is used to send the data. And in the standalone, different bands are allotted to send the data. These are the references I have used. I'll be also sharing the book, the first book. This is very good book. Quickly, if I have any question, please. I now request you to please open your camera so that I can take the some of the snapshots. If possible, you can open your camera. I should not have been rushed through all those things, but already one speaker is scheduled at 2:30, so I cannot take your lunch time because lunch is also required. So if you have any question regarding this 5G, I mean, we can discuss. There is no problem. In fact, here our institute, we used to teach this 5G communication for this IoT in much detail. So if at any point of the time, if you have having any question or any doubt, you can just type me a mail or we can discuss, right? And if you have any question related to this, we can discuss right now. There is no problem. Still, we have 4-5 minutes. Now I have taken the snapshot. If you want, you can switch off your camera. Thank you. So if you have any question, Okay, quickly I'll summarize the 5G thing. So listen, when 5G evolved from the 4G, so it was not only the data rate they are targeting, they are also targeting some of the different aspects, like the number of devices can be connected, what is the latency, what are the number of devices that can be connected to a particular network. So these are the things they have keep into the mind for the application of IoT, and then they have designed the standard for that. And frankly telling, there may be coming some of the more IMT requirement, which will serve more of the application of IoT, because application of IoT cannot be limited, right? So that's why we can have a lot of application of IoT. And IoT, the 5G will follow the same OSI model, nearly the same, not the same, nearly same OSI model, which we are already aware of. Okay. For tomorrow class, if time permits, I'll need to have some of the volunteers, and then we'll do one of the session. I'll not say it's lab session, it's some kind of implementation session we will do. So I'll need maybe 4 or 5 volunteers. Okay. So if you don't have any question, I think I should stop over here. So we'll meet at 2:30. Okay, thank you. How to select the volunteer? Okay, I mean, tomorrow I'll ask if someone is ready to install a program in his or her phone, they can volunteer. There is no problem at all. Or you can subscribe, like there may be more than 5 volunteers also. There is no problem at all. Right. Okay, thank you. We'll meet after the lunch.